here to read our chapter 2 of The Number Devil. Which, as you know, today I'll give you 2 chapters this week, but I'll do them in separate videos. So here's chapter 2, and then the next video will be chapter 3. So, the second night. We read last week a little bit about kind of what's going on here. We got a guy named, a boy named Robert, and he has nightmares, and so all of a sudden he went from those falling nightmares or the sliding and not being able to stop. I don't know if any of you have had those when you like shake yourself awake when you get scared enough. And now he's got a new character in his dreams called the Number Devil, which he is not super stoked on. They got into an argument about just like what's the point. He obviously is not super fond of math as it is, which I think most of us can relate to some degree or another. And so it's a book about, oh, there's a cat, about general concepts that, mathematical concepts that the Number Devil is trying to show him that it doesn't have to be as scary as maybe it seems like it would be. So for now, we're just going to, for the sake of not wasting any more time, we're just going to ignore this cat. Kitty Scooch! Okay, cool. All right. Robert was sliding. Uh-oh. Because remember, this is the second night, so we're back in the consciousness of his dream, okay? Robert was sliding. The same old story. It had started the minute his head hit the pillow, and he couldn't stop. This time he was sliding along a tree. Don't look down, he thought, clinging to the tree for dear life and sliding on and on. Then all at once, he landed with a plop on a soft bed of moss. He heard a giggle, and who did he see but the Number Devil, perched on a velvety brown mushroom, smaller than Robert had remembered, and staring down at him with his shining eyes. How did you get here? He asked Robert. Oh, he asked Robert. Excuse me, that's the Number Devil talking. How did you get here? He asked Robert. Robert pointed to the tree trunk, which stretched as far as the eye could see. But it was not alone. There was a whole forest of them, and they weren't so much trees as ones. Okay, so it's a forest made of ones, and on the next page there's a good picture of it. He landed in a forest of ones. But that was not all. The air hummed with tiny fly-like numbers dancing in front of his nose. He tried shooing them away, but there were too many. 2s, 3s, 4s, 5s, 6s, 7s, 8s, and 9s kept brushing against him. Robert had always hated moths and gnats and couldn't stand having the beasties around. So basically, this is a forest full of ones. And then you see the Number Devil sitting on his brown mushroom. And then there's this little cloud of white digits that's flying around like a cloud of mosquitoes or something. And so he's like, bah! Are they bothering you? Asked the Number Devil. He put his hand to his mouth and blew them all away with a... Suddenly, the air was clear of everything but the forest of ones reaching up to the sky. You see the ones? Have a seat, Robert, said the Number Devil. Robert was surprised to find him so friendly. Where, on a mushroom? Why not? But I feel silly. Where are we, anyway? In a picture book? Last time you sat on a spinach leaf and now you're on a mushroom? I seem to remember something like that in a book I read once. The mushroom in Alice in Wonderland, perhaps. But what's the connection between a made-up story and mathematics? The kind of connection you make when you dream, my boy. You don't think I was behind all those flies, do you? No, I'm wide awake. You're the one in bed dreaming. Now what do you say? Are you going to stand there forever? We might if I can't turn this page. Here we go. Robert saw he had to do something, so he clambered onto the nearest mushroom. It was enormous, and except for a few bumps, as soft and cozy as an armchair. This is an armchair, but it's not super cozy because it's antique and anyway, old-timey doesn't always equal comfort. How do you like it? It's fine, said Robert. I just wonder who came up with the number flies in the forest of ones. I couldn't have, not in my wildest dreams. It could only have been you. And if it was, said the number devil, preening himself on his mushroom, though there's still something missing. What? Nothing. I mean, 0. He was right. There hadn't been a single 0 among all the flies. So in these clouds of digits, there was never a 0 digit. And these 1 trees, there's just nothing about zeros going on in here. And so he points out to Robert, and Robert says, why? Because 0 was the last number to be discovered, which isn't surprising, given that 0 is the most sophisticated of the numbers. Here, look. And finding a space between 2 tree-high 1s, he wrote some letters in the sky with his walking stick. M-C-M. Tell me, when were you born, Robert? Me? In 1986, said Robert a bit reluctantly, which I was discovering, I think this book must have been written a while ago, because I was born in 1984. So this kid's only 2 years younger than me, and in the pictures, he's a little boy. So, must have been written a while ago. Anyway. MCMLXXXVI. So this purple right here is what the number devil wrote. I know what those are. Those are those old numbers you sometimes find in the cemetery. And they come from the ancient Romans, who had a tough time of it, by the way. Partly because their numbers were so hard to read. Though this one is easy enough. The capital I is 1. 1, said Robert. And this, the X. X is 10. Right, and this, my boy, is the year you were born. MCMLXXXVI. The first M means 1,000. C is 100, but because it comes before the second M, you must subtract it to get 900. L is 50 and X is 10. You add them together, which gives you 80. V is 5, which you add to our friend 1 to get 6. So this is 1,000 plus 900 plus 80 plus 6. So basically this number in Roman numerals is what we know them as. Roman numerals, this number here would say 1,986, or if you're talking about the year, you would just say 1986. So basically we're saying the M is for 1,000, and then we say 100 years before another 1,000, which would be 900. So 1,000. Here's our 900. What was L? L is 50. 50 plus 3 tens would be 80. And then you have, so there's your tens place, right, is 80. And then 1 after 5 means 6. So this is 1,986 is this long list of letters. Gosh, that's awful complicated. Right again. And you know why? Because the Romans had no 0. I don't see the connection. Besides, what's so great about 0? 0 means nothing. Which is precisely what is so brilliant about it. But why even call it a number? Nothing doesn't count. Don't be so sure. Remember how we divided up that piece of chewing gum among all those billions of people and hundreds of billions of mice? And how the portions got so small that in the end you couldn't see them, not even with a microscope? Well, we could have gone on forever without ever reaching 0. We'd have come closer and closer, but we'd never have made it. So in chapter 1, when we talked about that piece of gum, if we were to cut it, divide it equally among, let's say, I mean, in the example they said like every living human and then every living mouse and, you know, every living creature on the entire planet, let's say. Now, because we started with a stick of gum, we can't say that everyone gets nothing. No, there was a something we started with. So everyone gets this tiny microscopic piece that, as you see here, it says that you can't even see with the microscope, though I think probably in 2020 we do have microscopes. I don't know. That would be a really teeny tiny piece of gum. So the point being is that everyone gets something, even if it's a tiniest little atom or something that we can't see, we can't touch, we can't quantify. But it's not 0 because you're getting something, right? Now, every person we add into the mix, say this cat, that cat, I'm sorry, I got a lot of cats here. You cut it up smaller, they're getting something, but every time you add more people that you're cutting it into, everyone gets less and less, and you're getting closer to 0. But because you started with one piece of gum, you'll never get 0 because everyone's going to get something. And that's kind of one of those hard concepts to understand, is that like if you ever stop and think about how big the universe is beyond the planet, those kinds of things where you have to like, wait a minute, hold on. You have to be able to imagine things that you can't see or feel or experience. So, and I think that's one of the hardest parts of math, is this idea of like, as things get smaller and smaller, there might be something there. So we can't say it's 0, but man, are we getting close to 0 where it's just not 0 because there's something there, even the tiniest bit. So anyway, that's what he's trying to get at right here, is that we would get close to 0, but we'll never hit 0. So now he wants to try to, how can we talk about 0 now? So Robert's like, so we've got to try something else. Minus, for instance, or subtraction. We would use the word subtraction. Yes, that should do the trick. He stretched out his walking stick and tapped the end of one of the ones, so like one of the trees. It shrank and shrank until it stood meek and manageable at Robert's feet. So it used to be the size of a tree, and now it's like as tall as his foot. Shouldn't be very tall. Go at it, said the number devil. What do you mean? Try the minus. So try the subtraction. 1 minus 1. 1 minus 1 is 0, said Robert. Everyone knows that. You see how necessary 0 is? You can't do without it. But why do we need to write it? If nothing is left, why not just leave a blank? Why invent a number for something that doesn't exist? Try this then. 1 minus 2. That's easy, Robert said. 1 minus 2 is minus 1. Or as we would call it, negative 1. Right, but look what you get without a 0. So here we've got this sequence of numbers that looks very similar to a number line, right? So we've got 4, 3, 2, 1, negative 1, negative 2, negative 3, negative 4. I mean, it's kind of a backwards number line, right? Typically we get larger as we go that way and smaller as we go that way, but it's a sequence of numbers. It's on that list of numbers that are related somehow. Okay? So, the difference between 4 and 3 is 1. Between 3 and 2, 1. Between 2 and 1, 1. So he's basically looking, oh my gosh, don't drop it, that the difference between 4 and 3, there's a difference of 1 there. The space between 3 and 2 is 1. Between 2 and 1 is 1. And then he said, the number devil says to Robert, and between 1 and minus 1? 2. Which means there must be a number missing between 1 and minus 1. So if we were just counting down, let's say we're counting down, there's a difference of 1, 1, 1, difference of 2, 1, 1, 1. Because if we jump from positive 1 to negative 1, positive 1 to negative 1 on a number line, we have to hit that 0 before we can go, because that's a jump of 2, right? We go positive 1 to 0, 0 to negative 1. Whereas all these other jumps are only of 1. So if we were to label these points on a number line, for example, they would not be evenly spaced. We'd have this bigger gap right in the middle, and then everything else would be 1. And so that's what he's trying to point out. That tricky little 0, I told you we couldn't do without it. That brings us back to the Romans. They reckoned they could. And that means that they thought that they'd be able to. And look what happened. Instead of 1986, they had to fiddle with all those M's, C's, L's, X's, and V's. The Romans had to give each number a different letter, all because they didn't have 0. But what they got, but what's that got to do with our chewing gum and the minus? Forget the chewing gum, forget the minus. The 0's real beauty lies elsewhere. But you'll need to use your head to appreciate it. Are you up for it, or are you too tired? No, as long as I'm not sliding, I'm fine. In fact, I like it here on the mushroom. Good. Then let me give you a little problem to solve. Why is he suddenly being so nice to me, Robert wondered. I bet he's got something up his sleeve. but all he said was, fire away. Okay, so Number Devil's giving Robert some questions, some math questions, and he's like, I feel like there's a trick here. He's being really nice, but all right, give them to me. Let's do them. So the Number Devil asked 9 plus 1. 10. Robert answered like a shot. Is that all? And how do you write it? I haven't got a pen. Then Sky write it. Here, take my walking stick. So he does 9 plus 1 equals 10. Robert wrote in purple cloud script. So he used the writing devil, or the writing devil. It's a different book. It's about writing. No, I'm just kidding. The Number Devil's walking stick to write in the sky. 1 and 0? The Number Devil said. 1 plus 0 doesn't equal 10. Oh, come off it, Robert shouted. I didn't write 1 plus 0. I wrote a 1 and a 0, and that's 10. And why, may I ask, is that 10? Because that's the way you write it. And why do you write it that way? Why, Robert moaned. You're getting on my nerves. There he is writing the magic walking stick. Well, I said it's magic. I don't know if it's really magic. Want me to tell you? The Number Devil asked, leaning back leisurely on his mushroom. A long silence followed. Fine, go ahead, Robert blurted out when he couldn't bear it any longer. Simple. It comes from hopping. Hopping? Robert said scornfully. What's that supposed to mean? Numbers don't hop. Numbers hop if I tell them to hop, the Number Devil replied. Don't forget who you're dealing with. All right, Robert said. Just tell me what you mean by hopping. Gladly. Let's get back to square one, or rather the number 1. So we've got some 1 times 1, 1 times 1 times 1, 1 times 1 times 1 times 1, and they all equal 1. Tack on as many 1s as you'd like, and you'll still get 1 for your answer. Sure, but what's your point? You'll see if you try the same thing with 2. All right, Robert said. 2 times 2 equals 4. 2 times 2 times 2 equals 8. 2 times 2 times 2 times 2 equals 16. 2 times 2 times 2 times 2 times 2 equals 32. Wow, that goes fast. If I go much further, I'll need my calculator. So what it means by that goes fast, what I'm assuming, what I'm inferring, the first few times I read this, I was like, that goes fast. What I'm assuming Robert means about going fast is that, do you see how these numbers are getting much larger pretty quickly? It was a 1 digit, 1 digit, 2 digit, 2 digit, so they're kind of like, every time you tack another 2 on, our numbers are getting bigger and bigger. And so he's like, man, if we keep going, I'm going to need a calculator because these numbers are going to get real big. It goes even faster if you start with 5. Why don't you give it a try? 5 times 5 equals 25. 5 times 5 times 5 equals 125. 5 times 5 times 5 times 5 equals 625. 5 times 5 times 5 times 5 times 5 equals 3,125. And then 5 times 5 times 5 times 5 times 5 times 5 equals 15,625. Whoa, Robert shouted. Why do not large numbers make you so jumpy? I can assure you that most large numbers are perfectly harmless. So it's that idea of these numbers got even faster, right? By getting big quick. Like, woo, these numbers are getting big. Every time we do a new row, that product, that final answer to that multiplication problem is getting really big. Says you, said Robert. Besides, I don't see the point of multiplying 5 by itself over and over. I'm coming to that. You know what the Number Devil does instead of writing all those boring 5s? He writes, so here we've got 5 to the first power is 5. 5 to the second power is 25. 5 to the third power is 125. And so on. And then he says it. He narrates it. 5 to the first, 5 to the second, 5 to the third. In other words, I make the numbers hop. Now do you see? Do the same with 10. So basically, real quick, before we move on, here, so we didn't have just a 5 by itself, but 5 to the 1 is equal to 5. Do you see how here we've got 2 5s is equal to 25? Well, here we just wrote a big 5 and a small 2, and that equals 25. And then down here, we've got 3 5s. 5 times 5 times 5 equals 125. So we can just write the small little 3 there to say how many 5s we're multiplying in order to get this answer, okay? And it's hard to tell from here, and depending on what grade you're in, you have experience with these 6th graders a little bit less, but we talked about it a little bit. This idea of the big number is what number you're multiplying, repeated multiplication, and the little number is just how many times. So here we've got 5 times 5 times 5 because there's a small 3 there. And if we go back to the long way to write that, we get the same product, okay? Now, do you see? Do the same with 10, and it's as easy as pie. You can throw your calculator away. Make the 10 do 1 hop, and it remains exactly as is. So basically the hop is like hop into the place value. Right, there it is. Now, make it hop twice, and you get 10 squared is equal to 100. Okay? So basically now, it's hopped into its place value and then over 1. And then it hops 3 times, you get 1,000. So if I make it hop 5 times, Robert cried, I get 100,000 once more, and I get 1,000,000. So he's kind of starting to notice that when you have, when it hopped, like here we hopped 3 times and we had 3 zeros. Here we hopped 2 times, we had 2 zeros. We hopped once, we had 1 0. And so he's able to notice the pattern and say that if he does 10 to the 5th power, he's going to have this number 100,000, which is a 1 followed by 5 zeros. Okay, so he's noticing a pattern, which guess what? That's all math is. Patterns. So, take a note from Robert. Hates math, still finds patterns. And then he says if he does it once more, which would be 10 to the 6th, he would have 6 zeros followed by, or starting, a 1 and then 6 zeros behind, which is 1,000,000. And so on until the cows come home, said the number devil. Simple, eh? That's the beauty of the 0. It lets you hold a space and move on. You can always tell a number's value by its position. The farther to the left it is, the more it's worth. The farther to the right, the less. That's old news. You guys have been practicing that since elementary school, so we're good there. When you write 555, you know that the last 5 is worth exactly 5 and no more. The next to last 5 is worth 10 times more, because it's the tens place. That is 50. And the first 5 is worth 100 times the last one. That is 500. So basically place value is all this is reviewing. And why? Because it's been hopped up front. So you have the same digit 3 times in a row, and we're not talking about multiplied together. That's not what we mean necessarily. We just mean the number 555. We're saying every time it hops over, it's 10 times larger than it was the first spot it was in. So when it hops over twice, now it's 100 times bigger, which is basically just how our place value chart's set up, right? 1, 10, 100. We're multiplying by 10 every time we jump over. Okay? Now, let's see. Now, the 5s of the ancient Romans could never be anything but 5s. Why? Because the Romans didn't know how to hop. And why didn't they know how to hop? Because they had no 0 to keep places, which meant they ended up with monstrosities like MCMLXXXVI. So basically he's saying that we have a 5 and we could put it in any place value location and therefore give it a value. We put the 5 in the hundreds place, it's 100. We put the 5 in the ones place, it's 5. Put the 5 in the millions place, it's 5,000,000. But the Romans did not have that. They were missing this idea of 0, which basically would hold the place value of all those. If it hops over here to the millions place, then all the rest better be zeros, right? And they didn't have that, so they're like, so they have this 5, but they have to somehow describe to their audience how is that 5,000 or how is that 5 whatever. And instead of being able to just put it in a spot and you recognize what it is, they had to find other ways to make those numbers make sense, which as you can tell is much more complicated than our place value system, right? So he's basically telling them Number Devil's telling Robert, be grateful, Okay, so he says, "So rejoice, my boy, you're much better off than the Romans. With the help of friend Zero and a bit of hopping, you can produce any number, big or small. Any number you please. 786, for instance. But I don't need 786. Really now, you are brighter than that. Try the year you were born, 1986. The number devil started growing again, so he's getting bigger. And his mushroom followed suit. So you can see in this little picture, his mushroom is getting larger. As he gets big, the mushroom gets taller. Well, what are you waiting for, he bellowed. Get a move on. There he goes again, thought Robert. Get him worked up about something, and he's impossible. Worse than Mr. Blockell. That's probably, I can't remember from chapter 1. I think it's his teacher. But basically, he's noticing that the number devil is getting angry, and then he's like, not fun to work with when he's upset. Much like most of your teachers. He carefully wrote a large 1 in the sky. So he told him to write the number 1986 or the year 1986. So he starts to write the 1. Wrong, the number devil screamed. Dead wrong. How did I wind up with a fool like you? I told you to produce the number, not scribble it down. So he said, don't write it, do it. Show me how you build that number. Where did that number come from? Robert would have given anything to wake up. I'm not going to put up with this, he thought, watching the number devil's head swell up and turn redder and redder. The end, the number devil called down to him. Robert stared back, completely at a loss. I think some of us have experienced that in class, right? Sometimes it's me, sometimes it's students, whatever. We work together. We're a team. Start at the end, not the beginning. If you say so, said Robert, who was in no mood to argue. He erased the 1 and wrote a 6 in its place. Finally caught on, have you? Well then, we may proceed. No problem, said Robert warily. Though I'd appreciate it if you didn't fly off the handle over every detail. Sorry, but what do you expect? I'm the number devil, not Santa Claus. How do you like my 6? The number devil shook his head and wrote. So he wrote the number 6 because in this number 1986, the 6 is in the 1's place. And he told him to start at the end, which as we know in math, in whole numbers, right, from our education, whole numbers start with the 1's place. We start there and we move that way. So he's like, no, the end, not the beginning. So he writes the number 6 and he's like, that's a good 6, right? You like it? And he's like, no, I meant 6 times 1 equals 6. But that's the same, Robert protested. You'll see what I have in mind. Now comes the 8, and don't forget to hop. Suddenly, Robert did see what he had in mind. So he wrote 8 times 10 equals 80, right? So that times 10 is a hop. So the 8 hopped over once. Whereas when it was just times 1, the 6 just stayed there. But then when it was times 10, the 8 went whoop and hopped next door over to the 10's place. I get it, he shouted before the number devil could tell him what to do. With 9, I make the 10 hop twice. And he wrote. So basically, he had the 9, and now it's times 100. So he goes boop, boop, and he jumps over twice. Now he's in the hundreds place. And 1 times 1,000 equals 1,000. That was a triple hop, he said. And now for the grand total. 6 plus 80 plus 900 plus 1,000 equals 1,986. It's not so hard after all. I don't even need the number devil. So you don't need the number devil, eh? You're getting too big for your britches, boy. All you've had so far are the most ordinary numbers. Nothing to write home about. Wait till I start pulling numbers out of my hat. All kinds of numbers. Unreal numbers. Unreasonable numbers. You have no idea how many kinds of numbers there are. Numbers that run around in circles. Numbers that play tricks on your brain. Numbers that go on forever. As he spoke, his grin grew wider and wider. Kind of looks a little Cheshire catty right there, right? Robert could see all the teeth in his mouth. That was a really big smile. They seemed to go on forever. And then he started twirling his walking stick in front of Robert's face again. Help! Robert screamed and woke up. So he woke himself up. Still in a daze the next morning, Robert said to his mother, "Do you know what year I was born? It was 6 times 1 and 8 times 10 and 9 times 100 and 1 times 1,000. "I don't know what's gotten into the boy lately," said Robert's mother, shaking her head. "Here," she added, handing him a cup of hot chocolate. "Maybe this will help. You say the oddest things." Robert drank his hot chocolate in silence. There are some things you can't tell your mother, he thought. So he doesn't want to talk to mommy about his nightmares, right? And I think most of us, because we're middle school aged, I say us, I mean you guys, not me, but you're old enough to remember, be like, okay, that was a weird dream. I don't need to go talk to everyone about it. Or you're just like, why does this feel so real? Why is this so interactive? Whatever. So he doesn't want to tell his mom. So what I really like in this chapter is we talk about the significance of the number 0 and that there are number systems that don't have 0. And without 0, explaining things and the lack of things gets real tricky. So we are very lucky that our number system is set up the way it is now that everyone's discovered all the things that we need to know to make our lives easy. It kind of gives a different meaning to that whole Zero the Hero. I know when you're in kindergarten, there's like a Zero the Hero song, and